Hi everybody, welcome to our 11.5 notes. This week I'm trying out a headset. You guys can let me know if it helps with the sound quality at all. For 11.5 we're looking at formulas and further applications, so we're going to have a word problem day and it's going to be awesome. But first we're going to start with formulas. So with the formulas part, what you're doing is just rearranging a formula for a different variable. So in part A, we have A equals pi r squared. So you might notice that one is area equals pi r squared, which is area of a circle. We're going to rearrange this formula for r, for the radius. So if I want to solve for r, it's really regular equation solving rules. So I'm going to divide by pi because it's multiplied. So if I divide both sides by pi, I'm going to have A over pi equals r squared. And then to get rid of the squaring, you're of course going to take the square root of both sides. For this one, normally we do the plus or minus square root, but a negative value for our radius doesn't really make sense. So we're just going to do the positive version. So we'll have radius equals the square root of A over pi. You can rationalize it if you'd like to, because we would have a square root of pi in the denominator. To rationalize it, we would multiply the numerator and denominator by the square root of pi. So then that would simplify to the square root of A times pi on top, and the square root of pi times the square root of pi, which would just be pi in the denominator. And that's it. Let's see, the next one I have S equals 30 times the square root of A over P, and we are solving for A, so A is right here. So to get A by itself, let's go the easy way. Let's go ahead and get 30 out of the way. So if you want to get rid of the 30, it's multiplied, so let's divide both sides by 30. So S over 30 equals the square root of A over P. And A is inside of a square root, so let's go ahead and get rid of that square root so we can deal with the A and the P. The opposite of square rooting is squaring, so I'm going to square both sides. So then I'll have S squared over 900 equals A over P. And last but not least, I would like to get rid of the P. I would like to get A by itself. So it's divided by P, so the opposite of dividing would be to multiply. So I'm going to multiply both sides by P. So then I'm going to have A equals P times S squared in the numerator, and 900 in the denominator. And that would be it. Okay. So next up, let's use a formula to solve a problem. Using the Pythagorean theorem. So a quick little refresher for those of you who need it. The Pythagorean theorem says that A squared plus B squared equals C squared. For the sides of a right triangle, A and B are the legs of the right triangle. Those are the sides next to the right angle. And C is your hypotenuse, which is the longest side in a right triangle. Okay? So find the lengths of the sides of the right triangle. So it doesn't have it marked, but it should. This is the right angle right here. And my side lengths, I have 2x plus 12 is one of my legs, 3x is another leg, and 5x is my hypotenuse. So when I'm setting this up, it's really up to you which one you decide is your A or your B, because we've got two legs, but these are my two legs right here. So I'll have 3x squared plus 2x plus 12 squared, and then my hypotenuse is right here. It's 5x, so equals 5x squared. First thing, of course, you'll have to do is square everything. So when you're doing 3x squared, that would be 9x squared, so it's 3x times 3x. When you're doing 2x plus 12 squared, what you're actually doing is 2x plus 12 times 2x plus 12, and then you do need to distribute. 2x times 2x is 4x squared. 2x times 12 is 24x. 12 times 2x is another 24x. And 12 times 12 is 144. On the right side of our problem, we have 5x squared, so that would be 5x times 5x, which is 25x squared. At this point, I can tell you it's going to be a quadratic. I have a lot of x squareds, and they don't look like they're canceling each other out anytime soon. So to solve a quadratic, I'm going to go ahead and get it in standard form, where I have everything on one side, and the equation equals 0. So I'm going to subtract 25x squared from both sides. So looking at my x squareds, 9x squared plus 4x squared is 13x squared, minus 25x squared is negative 12x squared. Looking at the x's, I have 24x plus 24x, which is 48x. And looking at the constants, I have a plus 144 equals 0. At this point, one thing I notice is that 12, 48, and 144 are all divisible by 12. And to make my life a little bit easier, I don't really like having a negative leading coefficient. So what I'm going to do is divide by 12 on both sides. I'm actually going to divide by negative 12 to make that a positive leading coefficient. And that makes my life a whole lot easier. So negative 12x squared divided by negative 12 is positive x squared. 48x divided by negative 12 is negative 4x. 144 divided by negative 12 is negative 12. And 0 divided by negative 12 is 0. And that's a lot easier to solve than the quadratic I had above. From here, it's really up to you. It does factor nicely, but if you would rather use the quadratic formula or completing the square, you're certainly welcome to do so. Okay? But it does factor nicely. So x times x is x squared. Negative 6 times positive 2 is negative 12. And 2x minus 6x is negative 4x. So that's how I know that that was the right choice. Equals 0. From here, I would have x minus 6, my first factor, equals 0, which means that x is 6. With x plus 2 equals 0, I would subtract 2, so x would be negative 2. Then we're trying to find the lengths of the sides of the triangle. If I plug in negative 2 even to 3x, I would have a side of negative 6, which doesn't make sense. So that one's actually not going to work out very well for us. But let's look at 6. So for 3x, that side, we would have 3 times 6, which would be 18. For my 2x plus 12 side, I would do 2 times 6, which is 12, plus 12, which is 24. And for my 5x side, I would do 5 times x, so 5 times 6, which is 30. And so the side lengths for my right triangle are 18, 24, and 30. They didn't give me units, so, well, you leave them unitless, okay? Let's do another Pythagorean theorem problem. 2 cars left an intersection at the same time. One of them is heading due south, the other due west. So in our picture, they started in the corner, and one of them is heading south, and the other one is heading west. Okay. Sometime later, they were exactly 150 miles apart. So on our picture down here, this is where the cars ended up. So the 150 miles apart is our hypotenuse. The car heading south, which would be this one right here, had gone 30 miles farther than the car heading west. So if the car heading west, let's just make that one an x, because I don't know how far it went, then the car heading south is 30 miles farther than that car, so it would be 30 more than x, or 30 plus x. How far had each car traveled? And another thing that I know is that due south and due west are perpendicular to each other, so it forms a right angle. So if you notice as I'm going through the problem, I'm drawing a picture so that I know where everything is. I'm also dissecting that information so that I can complete my drawing or my diagram. Okay? So how far had each car traveled, we need to go ahead and set some sort of an equation so that we can solve for x and solve for 30 plus x. Since it's a right triangle and we're solving for side lengths, that should give you a really good hint that we're using the Pythagorean theorem again. So the Pythagorean theorem is a squared plus b squared equals c squared. I'm going to give you guys a moment, see if you can set up the Pythagorean theorem for this problem. Okay, so I'm going to pause the video and I'll show you the equation in 3, 2, 1. The equation you should get is x squared plus x plus 30 squared equals 150 squared. How'd you guys do? We do okay? Alright, from here, it's solving. So, yet again, I'm going to let you guys pause, and I'm going to let you guys see if you can solve it from here. You should have two answers, okay? We should have an answer for x and an answer for 30 plus x. So, yet again, pause your video, and I'll give you guys the answers in 3, 2, 1. At the end of all of this, you're going to get x is either negative 120 or x is 90. Negative 120 doesn't make sense for our problem. 90 does. So what that means is that the west car went 90 miles. And the car that was going south, the south car, went 30 more, which would be 120 miles. How'd you guys do on that one? Did we do okay? Great. If you would like to see this one worked all the way out, I will post all of my notes scanned for you all. Alright, next up is an area application problem. Suppose that a rectangular reflecting pool in a park is 20 feet by 40 feet. So I went ahead and made a rectangle for you all, okay? So one side length is 20 feet and the other dimension is 40 feet. The park gardener wants to plant a strip of grass of uniform width around the edge of the pool. So let's go ahead and draw what that looks like. So it's going to have this uniform width of grass going all the way around the pool, and I'll try to make it, uniform, but I'm not perfect. Okay. And it's a uniform width, which means every single dimension has the same exact width to it. Okay? He has enough seed to cover 700 square feet. So he's just covering grass here. We're not putting grass in the pool. We're just putting grass around the edge. Okay. And that area, so the shaded area is 700 square feet. Okay. How wide will the strip be? Well, let's go ahead and assign a variable for that. Let's just use x. So we'll say that the width is x. Okay? So let's go ahead and set that up. So first off, what I know is that the area for the grass is going to be 700 square feet. So let's set that up. So the area of the grass, if you notice, that's only the outer dimension here. It's not the pool. So to find that area, what we can do is take the whole area, the larger rectangle, and subtract out the pool because we're not going to spread grass seed inside of it. So the area of that shaded area, that grass region, is going to be the area of the outer rectangle minus the area of the inner rectangle. So that shaded region grass is 700 square feet. The outside rectangle, I don't know its dimensions yet. So I know that this much is 40. And then we're going to add x in this direction and to the right. We're going to add x in that dimension to the left. So really that outside length is going to be 40 plus 2x. For this vertical line here, Here it's 20 feet.